So if you guys have camera phones and stuff and you just want to take a picture of one thing today, take a picture of what the whiteboard looks like right now. So basically I've written everything down in my terrible handwriting, and I basically said, look, the mechanics are what can the players and system do and what are the goals. The dynamics are what happens. Again, very, very difficult, but if you have a spell or ability in the game that no one ever uses, then that's obviously a problem. And number 3, aesthetics, what does the player, or what do the players feel? And that's pretty much all. So if you're going to take a picture of anything today, let that be it. And that's all I'm going to say about that. So the next thing I'm going to be talking to you about is the tiered pyramid method. Subtitle being next generation game design, which sounds more like a buzzword than anything else. So the point is, where do I start with this? I mean, I'm going to be explaining throughout the course of how it came up or whatever. I just feel like I need to explain what the purpose of this whole thing is. So when I say next generation, I don't actually mean next generation just in the sense that we all know, like, well, you know, for new hardware or something like that. What I mean to say is for the next generation of games. Because a problem that we have right now, and have always had, but it's even more obvious at the moment, is the complexity of games is constantly increasing, and it doesn't really matter which platform you're on. If you're making mobile products right now, if you're making mobile games, then honestly, it's kind of like you turn back the clock a few years. No more than that. I mean, the mobile hardware is so advanced right now, and some of the products that are actually running on mobile right now are so cool. You've not really bought yourself all that much. I mean, there are a lot of people who look at the mobile platform and say, cool, here's a platform where we can still make, you know, indie style games that, you know, don't require that much effort. But to be honest, it's no more that way on mobile than on really any other platform. There are games that use Unreal Engine on mobile. So if you want to really make a badass AAA high production value game on an iPhone, that's actually possible today. So I think it's very important for people to respect this, and regardless of how they are approaching their development and which platform they're going for, to work in a way that's as efficient as possible. So what is the tiered pyramid method? So we're going to get into that now. First, I want to talk a little bit about me. Just like I said, we're going to do the introduction somewhere in the middle. Who am I? Well, first of all, I'm a Romanian-born person. I was actually born across the pond in Romania. At age 4, I moved to Sweden. And then at age 18, I moved to Canada. So the part in between 4 and 18, you don't have to worry about. Nothing fun happened. I worked in Canada working on games such as EA Sports, FIFA 2002, and this one James Bond game that no one remembers. I moved back to Sweden kind of like a year later, and worked at a company called UDS on games such as Futurama the game and a game called Reign of Fire. UDS actually went bankrupt not too much later, and I think if you'd played Futurama and Reign of Fire, you probably understand why. Then I worked for Avalanche Studios on games such as Just Cause 2, and The Hunter, which was the first game where I was actually lead game designer, before moving to England to work on Kinect Sports, My Coach 24/7, and Transformers Universe, and then finally moving to Germany, where I am making, or have been making rather, Might and Magic Heroes Online for a French company. So that's a lot of flags right there. Any questions? No? That's fine. So my current position, or my last position I should say, is a creative supervisor. I'm not really sure what that means. I was doing that job for 2.5 years. I still don't know. My previous positions include, in reverse order, various game and level design positions. I'm moving to a new job now where my new position is lead game designer. A dialogue coordinator position, so that's just what we called it. I mean, that was the word they used to make me feel better. I mean, what I was doing is I was sitting down and I was taking care of all the dialogue in some of the games that we were making. So I was looking at Excel spreadsheets every day, all day. and it got really frustrating. So you can imagine if you make a game like Just Cause or Just Cause 2, you can imagine how much dialogue and how much text is in there. So it's thousands upon thousands of rows in an Excel spreadsheet, and someone always comes by and says, hey, you know, I have a new string that I need translated into 3 new languages. And I say, how am I going to do that? The game launched last week. And they say, I don't know, work magic. And then I actually have to work magic. So yeah, don't do that job, by the way. QA positions, so quality assurance, working in the testing department and whatever, you know, seems like kids these days don't have to do that job. But when I was growing up, if you wanted to do anything else, you probably have to do QA first. Now, doing all of these jobs got me interested in production methodologies and management. Have you guys had any sort of training when it comes to production methodologies? Those kinds of things? No? Not at all? Okay. So, why? Why would I care about these things? Well, I consider myself a bit of an auteur games creator. I have a lot of really crazy ideas. Most people who get to know me and get to work with me actually don't think that about me. They think I'm very pragmatic and that I work a lot of, with a lot of, you know, very practical things and practical techniques, and I'm very realistic and all this kind of stuff. Actually, that's not me inside, so to speak. That's not what I want to do. I want to do a lot of really crazy stuff, but the problem is the realities of making games always stifled creativity. As I was going up through my career, I always find that the actual realities, the practical problems, money, staff, all these boring stuff, contracts, all these things always got in the way of doing all this fun stuff. And one thing that I noticed is if I don't actually have the control over all these more boring aspects, I don't get to do the fun things either. Because I very quickly learned that, hey, if I don't control, at least to some degree, the expanse, the complexity of my own vision, it's going to be very, very difficult for me to convince someone else to pay money for it. So if I show up to someone and say, I have the best possible idea for a game ever, and they say, cool, when is it going to be finished? And I answer, I'm not even sure if it's going to work. That's probably not the best sales pitch, right? So one of the things that I noticed was that game projects are basically 3 things in one, and I don't know if you've noticed this yet, but sure, they're a work of art. This is the part that a lot of game designers think is, you know, very, very important, and they say, oh, it's art, it's art, and I have a vision, and shit, it's art, right? They're very, very passionate about this stuff, like grand visions, and, you know, I want to make grown men cry, and all this stuff, right? But there are 2 more aspects. It's also an R&D project, research and development, right? So research and development is by its own nature risky, right? If you look at research and development from a scientific point of view, if you look at whether it's biology, whether it's chemistry, whether it's physics, whether it's, you know, new product development, whatever that might be, research and development by its sheer nature is actually very risky, because most people who engage in research and development don't actually know whether they're going to have a product at the end of it. That's kind of the thing. You do research, you try to make a product out of it, maybe you have one of those eureka moments, oh my god, we solved something that was amazing, and they say, can you sell something? No, but it's really cool, look at it, right? So that's the thing about R&D, is it's not necessarily something that you can sell to people, but it's always part of the game's development. It's always going to be in there, especially since most of the negotiations happen at this level. Where you try to sell someone a work of art, and you say to them, hey, I have this really cool idea and it's going to be super duper awesome or whatever. Cool, do you know that you can do all these things? Well, no, not really, but we're going to actually do some R&D during the course of the project and figure out how to actually do this. And they will sign up for the work of art, but the fact of the matter is that there's still an R&D project in there, and maybe you're not actually going to be able to deliver on the things that you promised. We'll get back to that. Finally, it's also a manufacturing job, which is very important to remember. So you guys all know what manufacturing means, right? So manufacturing is, you know, stuff comes in and you just hammer a little bit and then it goes on the conveyor belt, and you're actually just building something, whether it's with your hands or with machines or whatever, right? But so the manufacturing job is almost a little bit the opposite of the R&D project. The R&D project is where you try to figure something out that you don't already know, whereas a manufacturing job is throwing loads and loads of effort into doing something that you do know how to do, right? You are making stuff like graphics. You know how to make the graphics. Maybe there's nothing strange about making the graphics. You just have to do it. There's a little bit of art to it, but there's not really any massive risk. You know how to make a 16 by 16 icon. That's not the difficult stuff. You know how to make the UI according to a certain specification. So all these things together is kind of the content of a game, and I would say that during the course of my career, I realized that I had to be in control of all three of those in order to be allowed to make my precious games. Because if the only thing that I had any control about was my vision, the work of art, then these two could always kill me. They could always kill the vision, right? I have a great idea, except that it's based on R&D that we haven't done yet. And also, we don't know if we'll be able to make all of the assets and levels and all this other stuff. That becomes really difficult. So I realized that, hey, if I'm going to actually make a game, I need to be responsible and think about all of these at the same time. Now, let's talk a little bit about the method itself. So the road has been really long from my first idea to an actual method. I mean, there have been many revisions, and even the name has changed lots of times. So I think when I first got the idea was, I don't even remember when that was. I think it was during the course of The Hunter, but I thought, well, it would be cool to put all these things together that I've learned into something that I could kind of sell to people or give to people for free or lecture about or something. And you need a catchy name. Everything needs a catchy name, and I couldn't really think of something. At one point I just thought, maybe I could call it The Secret Game Design Techniques of Reasonably Intelligent Swedish White People. But yeah, this is not, you know, it doesn't really have that ring to it. The thing is, I'm still not done with it. This stuff is really, really hard. What I'm showing you right now is a work in progress version, and it's always going to be work in progress. I'm changing and updating stuff all the time. I'm leaving it to you to pick and choose. Use the parts that you want, throw away what you don't want. But when you're throwing something away, be conscious that you are throwing something away, and then when your project breaks apart, don't blame me. So anyway, a bit of background is important. Much of this was developed in a Scrum context, or at least in a context with Scrum terminology. Now, you haven't really been given any training in production methodologies at all. Has anyone actually heard Scrum? So a few of you have actually heard about Scrum.
A few weeks ago,
yeah?
There are some guys from Crytek who gave us some little terminology and the general idea of Scrum.
Right. Okay. I hope that was useful. Some of the terminology you will probably recognize from that then. But this is not really Scrum as such, but it's probably compatible with Scrum. No one actually does Scrum for real anyway. Everyone changes something that they don't like. Some concepts have probably been inherited because, you know, it's impossible not to steal stuff from everywhere. You don't even know that you're doing it. Also, this is not meant to be a full-fledged production methodology. It's not meant to cover absolutely everything. So I'm just throwing that out as a general disclaimer. This is ultimately more about design than production. Now, the point of the tiered pyramid method is to try to avoid failure in a responsible way. Before we can talk about how to avoid failure, we should probably talk a little bit about failure means. Why do our game projects fail? I think I could probably do an entire lecture just about that. This is not that lecture. First, let's start by defining failure. I actually use two failure definitions, personally. Number one is failure type A, which is a low level of quality. Now, this means lower than it should have been, right? So the game is not as good as it should have been. Of course, this is a little bit subjective. It's a bit depending on a lot of things, but we'll get to that later. Failure type B is excessive cost. Okay, so something cost way, way too much. Now, of course, these can and often do happen in the same project, right? But these are my failure definitions, and I thought it was important that when I talk about a project failing, you know that I mean one or both of these. Low level of quality. Let's look at that in a little bit more detail. So lower than it should have reasonably been. What I mean to say by that is I have actually been put on projects several times that were basically failing. Failing projects or projects that no one actually had any faith in whatsoever. They put me there because they were getting paid by someone else to put a designer on the project, and they said, whatever, go do it. This primarily happened when I was relatively new as a designer, and they basically said, oh, give the guy a chance, but it's one of those really low budget projects that no one really cares about. And I have ended up on these projects and managed to save them, so yay me, right? But I think that if you are put in that kind of situation in your design career, if you are ever put in a position of a project that is basically doomed to fail, and you still manage to get it out, and it turns out to be maybe a 75% game, something like that, I don't think that's a failure. Seriously, you did pretty well considering what you had. So I think it needs to be looked at in that context, right? If you make something decent out of a completely shitty situation, that's still good. But if you get 30 million euros and the game sucks, then shame on you. Straightforward? Yeah. Another way of looking at it is if you ask someone afterwards, after the project is over, hey, how do you feel about the game? And they say, all things remaining equal, we would have done it totally differently. In other words, if I knew today what I knew when we started the project, we would have done everything differently. If they say that, that's probably a failed game, right? That's their way of saying, yeah, the game sucks. Totally sucks. I'm never playing it again. Can you think of any other way of defining low quality? We don't have to make this interactive. I'm not going to force it. If anyone thinks of something, just keep it in the back of your head. And then we have the type B failure with excessive cost. Yes, this does mean actual money costs. That is the obvious one. But you know that you are dealing with amateurs when the only way they have of defining cost is money. Because there are more ways that this is going to cost. For instance, this is a big word. Brand equity erosion. So people losing faith in the IP. So everyone knows what a brand is? A brand like Adidas or Spider-Man or I don't know, BAU, that's a brand, right? Equity is the value of the brand, how much it's worth. This is not always easy to kind of quantify. And erosion is basically when something is eroded, it's basically diminished, right? So the value of the brand takes a hit as a consequence of your product. Let's put that in a very simple example. Let's say you're making Spider-Man games or Batman games. We were talking superheroes over there before. Not Superman games, absolutely not. But let's say you're making Spider-Man games or Batman games or something like that. And you make a really, really bad superhero game. And let's say it's a Batman game. And you make a bad Batman game and people get sick of Batman as a consequence of your game. That's bad. It's not bad right now. But it's bad next time you want to release a new Batman game, right? If your entire business model is make Batman games, you need to keep making good Batman games or you're in real trouble. So is that straightforward enough? Yeah? Okay. Then you have your manpower costs, or woman power. I prefer woman power personally. Hey, women work a lot harder. Guys just kick back and surf Facebook. So manpower costs, what does that mean? It basically means that, let's say that you're crunching. Everyone knows what crunch is? Crunch is when your employer pays for your dinner and then brags about it on Twitter and the entire industry hates them. That was a little Crytek joke, by the way. But yeah, no, I mean, this is basically when people get burned out, or they lose faith in the company, they quit after the project is over, or maybe they don't quit but they sit around doing mediocre work, hating working there. I mean, it matters, right? And this can come as a consequence of not just a bad game but a bad project. You've been working people way too hard, or people feel disrespected. There can be a million reasons why it takes its toll, but this is a cost. Don't think that it's not a cost. Even if your time and budget were perfectly managed, if by the end of the project, when you want to make the sequel, everyone has left the company because they hate you, then making the sequel is going to be more expensive than making the first game, when in fact it should be the other way around. Why? Because now you have to hire a brand new staff. The previous staff could have made a sequel like this. The new staff, they can't because they didn't make the first one. This is massive, and a lot of people sadly don't take this seriously enough. You got your intercompany relation costs, and these are kind of connected more than anything to the brand equity erosion, maybe a little bit to the manpower cost. So this usually happens when you have multiple companies working on the same project. So maybe it's you. You've got you.com, the best mobile game developer ever, and then you've got Turkcell or whatever sponsoring you, hypothetically. You guys make a shitty game, they don't like you as much anymore. Your relationship is a little bit ruined. Or it could be an outsourcing company. You're working with this Indian outsourcing company that thinks that you guys are a terrible client, and it creates friction, and for the next project they're not going to be as happy to work with you anymore, right? This is also a cost, and it's going to add up in the long term. Now think to yourself if you can figure out any other way of defining excessive costs. Now the important question is, why do projects fail, right? This is a set of statistics from PricewaterhouseCoopers. A small caveat, their failure definitions might be slightly different from mine, but what they have here is they have bad estimates and missed deadlines as the most common one. So what they're doing here is they're combining the first reason and the second reason people gave, and this one is the most popular. The other one is change in scope. So the size of the project changed during the course of the project, right? So you were coding along, everything's going really, really fine, and then suddenly, bam, it just became twice as big for whatever reason. You got a change in the environment. Doesn't necessarily mean your physical environment. It could be suddenly everyone has to work with different people than they thought they had to work with, or now suddenly we're working on Macintoshes instead of Windows machines, or it could be anything. It's insufficient resources, change in strategy, imprecise goals. And it's funny, when you keep looking at these, because you can do a Google search and find a lot more of these statistics. Here's another one where you have the biggest one, resistance by employee, inadequate sponsorship, unrealistic expectations, poor project management. Here's another one, other being really big there, but then you've got your incomplete requirements, lack of user involvement, lack of resources, unrealistic expectations. These are from different sources, and you see a lot of similarities. Here's another one. You've got lack of user input, incomplete requirements and specifications, changing requirements and specifications. If I were to look at all of these that we've seen right now and try to boil everything down, and just kind of have one sentence that summarizes what we've seen from all of these so far, is the problem has been trying to hit a moving target. So here's your target, and now it's moving, right? That's the simplest way I can define all of these. Now, the usual suspects. I don't know if anyone watches South Park. Anyone watches South Park? So usually people say, well, why does this happen? Why are people trying to hit the moving target? You know, what is this problem that's always popping up? Well, the thing is, it's not completely random. There is someone who is out to get you, who really doesn't care who you are or what you've done. He just wants to get you, and that someone is, of course, Man Bear Pig. So, okay, a few people got that one. No, it's not Man Bear Pig, no. There are 4 common issues. The thing is, every failed project that I have seen has had these following issues in common, regardless of budget size, team skill, or seniority, and the conceptual health of the game. So what I mean to say is the thing that is going to come up on the next slide has not been affected by any of these. Because usually this is the first thing that the people look to. They say, well, the reason the game didn't work was because we didn't have enough money. Or they'll say, oh, the team isn't really skilled or senior enough. Right? If they would have been more senior and more experienced, they wouldn't have made all those little mistakes. Or the conceptual health of the game. Oh, the core game idea is terrible. No? And they try to look at those, but the thing is, even when those have been perfect, I have seen projects that have gone to hell. Right? And why? Well, like I said, there are 4 main reasons. Number 1, over-reliance on upfront planning. So putting too much faith in planning stuff up front, doing your little Excel spreadsheets, you know, the exercise we did just before the break with the MDA stuff, if you were to do all of that and say, done, now the game is finished, that's over-reliance on upfront planning, obviously. Number 2, irreducibly complex components. We're going to look at that in more detail later. Number 3, poorly managed dependencies. Number 4, incorrect prioritization. And when you take all of these together, you get something that I call the jigsaw puzzle method. Does everyone know what a jigsaw puzzle is? Yeah. So, right, you got your normal puzzle and it's in small little components that you have to put together. I call it the jigsaw puzzle method. We'll get back to why. But let's look at these components one at a time. So let's look at number one first. Over-reliance on upfront planning. What does that actually mean in practice? How does it usually happen? Well, first, we do upfront planning and documentation. So someone comes to us with the game's concept and says, hey, we want to make this game that's about this guy that goes around shooting people in the face. All right. So we sit down and we do upfront planning and documentation. We just write everything down. We have a design document that's 50 pages. We have technical design document that's 50 more pages. We have a scheduling stuff. We have 1 million pages basically. We have everything done and we feel good about it. And then we assume that the documentation is actually how everything is going to play out. So we look at the documentation and say, yeah, no, this looks solid, and let's just assume that this is how it's going to work. Maybe we will throw in an arbitrary stuff happens buffer. So maybe we'll say, well, we think that this is how everything is going to play out, but let's add 10% of time just in case something doesn't work out the way we thought. But 10% is just someone pulled that out of thin air, right? The end result then, the contingencies prove to be painfully inadequate. So those 10% are not enough. And then drastic measures have to be taken in order to save the project. We're talking about crunch, scope cuts, delays with scope increases. Now, I know you guys haven't been doing this for very long, but I just want to see if anyone wants to raise their hands if any of this sounds familiar. Have you guys bumped into this yet? Right? So you write down a bunch of stuff and you depend on the stuff that you've written down, and then somewhere halfway through it all turns out to be bullshit. Right? Number 2, irreducibly complex components. This is difficult from a language point of view, but it's not really that hard. The idea is we start working on features and content in parallel, right? So everyone knows what a feature is. It's like mechanics, whatever, stuff that you can do in the game. And content is stuff like levels and graphics and art assets and stuff. And we're working on these two in parallel. Now the reason we're working on these two in parallel is, again, because we're depending on our written documentation. The written documentation says what we could expect from the features and the content. So everyone is just saying, okay, I'll do my stuff, you do your stuff. And then 3 months from now, we meet up and put them together and see if they work. Yeah. Now the problem then becomes that our features are irreducibly complex. People create irreducibly complex features. An irreducibly complex feature is one that you cannot test and that does not work unless it is 100% done. I don't know if you guys have been in this position yet. I don't know the size of your feature, but I see this all the time. People make features and content in the game that do not work and cannot be tested until they're 100% finished. Now the problem with that is if you have a feature that takes 6 months to do, then you're going to be wasting 6 months before you find out that it sucks. Because you cannot try it unless it is 100% done, right? Sometimes it's testable earlier, but usually it's kind of arbitrary. You don't really know when you'll be able to test it. So the end result becomes that the feature doesn't work out as intended. Content was being created, so over here you were making graphics and levels and stuff, assuming that the feature was going to be what was in the written planning, right? And then you're done with it and it doesn't actually work anymore, so you have to throw away the levels and the graphics too. For instance, you have a mechanic in the game for making ice levels, so that your character slides around on ice or whatever. And then for whatever reason, they don't actually manage to program the ice so that it feels good. So you have to throw away all your ice levels and your ice assets and all this other stuff that you've done for the ice levels. So that was completely wasted work. And in some cases, the feature itself ends up having to be discarded or reworked. So can I ask people to raise their hands if this sounds familiar? Then you have number 3. Now, poorly managed dependencies. So do you guys understand the concept of dependencies? So you have one thing over here, like we said with the content, where you can have it on the feature level too. So you can have one feature over here that depends on another feature over here. This doesn't work without this, right? Far too often, people don't make a big deal out of dependencies because our specs are so detailed, I don't see what could go wrong. Napoleon? He didn't actually say that, I just made that up. But consequently, you get something like this. Anyone played Minecraft? So a lot of people played Minecraft. That's good. So you get something like this. So this is not what actually happened with Minecraft. I'm just using their assets. But you get something like this. Someone makes a crafting system, right? And they finish this part first. And then 3 weeks later, they actually finish the items that go into the crafting system. What's wrong with this picture? Okay, this one is not done until that one is done, right? They are dependent on each other. If you can't craft something, what is this for? It doesn't do anything, right? Now, why is this a problem? Because by the time that thing gets done, you will actually know whether or not you're done with this. The problem is people don't think that way. Way too often, they just go, this is finished, checkbox done. We're on schedule, everything's fine. 3 weeks later, you get that, you get actually all the items and all the things that you can put into the crafting system. You try it out, this thing breaks. It breaks like a 20-year-old bicycle that's rusted to pieces, right? It's just completely broken, and you have to redo it. And obviously, your publisher or whoever else is going to be really angry. You told them the crafting was done. No, it's not. It's going to take another 3 weeks. It kind of sucks. When you have a burn rate of 70 people whose staff you have to pay, and I know this is not the size of your projects, but imagine that on a really large scale, you'll understand why a lot of publishers don't like making AAA games anymore. Because you mess up something like this, and you have to pay a couple of hundred people's salaries for 3 months longer than you thought. That hurts. I don't have that kind of money. So yeah, end result then. The feature breaks when the dependencies are delivered, like I said. Work has to be redone or discarded. Raise your hands if this sounds familiar or not. And then number 4, incorrect prioritization. So when people make their priorities, they prioritize work in order of risk. So what is the riskiest thing? But their definition of risk is not really the one that I would use, because oftentimes people say difficult is the same as important. Let's do the most difficult thing first, right? Because we might as well do the most difficult stuff first, because that will tell us if there will be any delays. The problem is oftentimes the most difficult thing to implement is not necessarily the most important thing. And the problem with doing very, very difficult things first is that if it turns out to not work, if it's not also a very important thing, then you've got nothing. For example, there's this classic story. I don't know if anyone remembers the Xbox game Fable. So some of the more nerdy among you will probably know this one. So this is a game partially made by a famous game designer. I don't know if I can call him that anymore. Peter Molyneux. And Peter is well known for, as some people call it, maybe stretching the truth a little bit, maybe being a bit optimistic, right? And at one point he said, oh, in Fable it's going to be so awesome. We're going to have trees growing in real time. So he said that at one point he was being interviewed by a journalist, and he thought the journalist didn't seem excited enough, so he made that up on the spot. We're going to have trees that grow in real time, and the tree will drop like an acorn, and you can take that acorn, you can plant it somewhere else, and a new tree is going to grow up in a few days. First of all, that's a terrible idea. That's just not fun. Why is that cool? That's just terrible. It's just, what is this, Farmville with a sword? It's terrible. But number two, the most important thing is, if you assume that difficult is the same as important, then that is a pretty difficult thing to do, relatively, from a technical point of view. So let's say that they would have spent a lot of effort to make that work before they did anything else. They did the whole tree thing, and they put it up front. That was the most difficult task, so they decided to do that first. When it turns out not to work, or when it turns out to be unnecessary, they've still spent the time doing it. So if you then don't actually use it for the actual game, why did you do it at all? And is it then correct prioritization? My submission is no. Question?
It's not a question, but I'm just going to share an anecdote. Like 3 weeks ago, we had another instructor, Adam Russell, who actually worked on the original playbook project.
Yeah.
He kind of said something similar to your explanation. He said that when he was like working, he was, I think, one of the AI designers of the playbook.
Yeah.
And he said that when they were like nearly close to the end of the project, and they were watching a press conference of Peter Molyneux, and he said that at the end, Peter said that there's going to be a multiplayer option.
Yeah.
And he said that all of the development team learned that at the same time with the press.
Yeah, no, I've had those experiences myself. I've been sitting through E3 press conferences with my friends and gone, what? No, seriously. But this is, I mean, that part aside, but this is also a very important thing to keep in mind is when you start making those kinds of promises to the press, of course the press are going to think that it sounds extremely cool, but they're going to think it sounds cool because they haven't seen anything like that before. And because they're going to extrapolate from that. They're going to think, oh shit, they have trees growing in real time. I guess the rest of the game must also be super awesome. But the real question to ask yourself is, what are your aesthetics, dynamics, and mechanics, and how the hell do those tree things fit into that? Would you play Fable in any way differently if you could plant your own trees? You would do it once or twice, but it has nothing to do with the rest of the game. So it's one of those things that if you make that promise and people want to see it in there because it sounds cool technically, you've done yourself a pretty serious disservice, right? So that's why this comes back to prioritization. Prioritize the things that are most important and that the person or the people will do most of the time anyway. Don't put a bunch of stuff in there just because it's difficult. Another problem, assuming that politically driven is important. Politically driven basically means that someone wants something. I don't care what it is, but someone who makes a lot more money than you and is probably paying your salary wants something because they want it, because it's none of your business to question them. This has been known to happen. I have been known to be very, very close to flying over the table and strangling someone because of this, right? That something is politically driven is not the same as it being important. I'm just going to put that on the table immediately. It's not. It may be in the absolute sense. It could be that the person says you either do this or I remove my funding. Sure, then it does become important. But we need to differentiate between the threat of losing the person's trust or losing the person's funding and what is actually important to the game, right? You may still do something political just to shut the person up. But we need to remember that technically, just because someone wants something, that doesn't actually affect what is really important in the game. Sometimes you see little incentives and quirks influence the prioritization of game projects. For instance, the publisher has a desire to mitigate risk up front. That makes perfect sense when you think about it. They have a project that they have estimated to be a, say, €5 million project, just to keep it modest. It can be a lot bigger than that, but let's say it's a €5 million project, and it's supposed to have a couple of features that seem a little bit risky, so they want to try them out as quickly as possible. Not an unreasonable request when you think about it. The problem with that sometimes is, though, that you end up in the same problem as up here. You're doing all these things because they're asking for it and because they think that these are very difficult things, because it's part of their final vision. But when you look at what the game actually ends up being, you could have made it work without those two things. But they're just so nervous, so sometimes you have to talk them down and say, guys, I know why you want to do this, but chill. We should probably try to get something playable first, right? Now another problem is that the developer wants the project to drag on. Now no one actually ever admits to this, but it does happen. For instance, some developers don't actually believe that they will ever see any royalties from the project. Indeed, some developers don't even have royalty clauses in their contracts. There are no royalties. You only work for milestone payments. So think like a game designer. If the only way you get paid is through milestone payments, you're going to want to get as many milestone payments as possible. So the longer the project goes on for, the longer you can pay rent and eat, right? There is no incentive for you to be done fast with the project, because then you need to find a new one and you don't know if you will. That's going to affect the prioritization. The publishers sometimes want flashy graphics and hacked demos. That's going to affect the prioritization too. Oh my gosh, E3 is coming. There's going to be an E3 show and we need to show a really cool demo. So drop everything else and make it pretty. And then people do that, and then afterwards they have to remove all the stuff that they put in for the E3 demo and go back to actually finishing the game. So that was an entire lost month of work, right? Bad prioritizations. And sometimes the developers focus on technical deliverables. So a technical deliverable is something that's related to the engine or technology, and usually the contract is written in such a way that the technology is owned by the developer, right? So if I keep the technology, it's in my best interest to get as many of the technology things finished as soon as possible. Because even if they cancel the game, I still get to keep the technology I developed. That's also going to affect the prioritization in an ugly way. So what you get then as an end result there is you get loads of work that has to be thrown away for all of those reasons, because people just prioritize wrong and go in the wrong direction. You get hacks and content that is built on those hacks. You get massive amounts of friction within the development team, between the developers and publishers, and with the consumers, right? Because consumers are not going to be happy when you release a game and you had this really cool looking E3 demo that was all fake, and by the time the actual game comes out, you've wasted so much work that you couldn't actually deliver that level of content all the way through. Raise your hands if this sounds familiar. So, how is this a jigsaw puzzle? We're coming back to this, right? Well, because this is your detailed spec. This is the documentation that you wrote up front, and you thought that everything was going to be so brilliant, just follow the documentation, it's going to be fine. But because of these other problems that we mentioned with the irreducible complexity and the cross-dependencies and the prioritizations, you ended up with this. Okay? So this part in the corner is missing because you had bad prioritization and you didn't actually finish it on time. This thing is also missing. This thing is just all red and weird. This thing doesn't really look like what it's supposed to. This thing is upside down and inside out in some weird way. It's not a perfect metaphor. It's not the best analogy ever, but you kind of get what I'm going towards. You're working on all these things in parallel based on a bunch of assumptions that everything is going to play out a certain way, and by the time it all comes together, you'll see that some parts don't fit, and that's when the real work starts. You're supposed to be finished, but you're not. And now starts the really difficult work, which is to try to fix all these problems without breaking something else. Have you guys heard this, this joke? It's based on this stupid American song, 99 bottles of beer on the wall, right? And someone sings 99 bottles of beer on the wall, you take one down, you pass it around, 98 bottles of beer on the wall, and you keep going all the way down. Well, there's the same joke, but with bugs, with computer bugs, and they say 99 little bugs in the code. You fix one bug and pass it around, 123 bugs in the code. It's the exact same thing here. Fixing this is horrendously difficult. Fixing the documentation is super easy. You just change text. It's the part in between that I'm doing this lecture about. How do you not end up over there? Okay? If you want to know, I mean, I don't have to tell you. And then what happens? Well, usually this. So this is from Oliver Twist. So you got the publisher, and he's got some money, and that's the developer. I wanted to be a political cartoonist when I was younger. I gave that up. But so this is my way of still doing a little bit of cartoons. Anyway, So what should we be doing instead? So first of all, can anyone tell me what this is?
It's a pyramid.
It's a pyramid. Okay, so you don't get to answer the next one. Okay, so who can tell me what that is?
Ziggurat.
See, it's whenever, see, this is so funny. When I do this with 5-year-olds, they get it right. They say pyramid the second time too, right? Yeah, people always over-intellectualize it. Yes, but it's still a pyramid. At its core, it's still a pyramid. I mean, you didn't call this an Egyptian pyramid, right? So these are just pyramids. They kind of look different. The point is, people have an easy time of over-intellectualizing this, but the most important point is that compared to the jigsaw puzzle example that I showed you guys before, no one can say that one of these is better than the other, right? Unless you're like an Egyptian pyramid fanboy or something. But no one can actually say that either of them are really broken, right? Does either of them really look broken? I mean, this one is a little bit chafed and what we know, but it still looks kind of like it's supposed to. The jigsaw puzzle was obviously broken, and the end user will know that it's broken. Have you guys ever played a broken game? You know what a broken game feels like, right? As far as any of us in this room knows, this pyramid might have been meant to be several floors higher originally. But because of how it was built, we won't know, and it doesn't look broken. Kind of same thing right here, right? It has this little temple-y thing here at the top, but with a little bit different type of building, you could probably still have had that at the top and still have it be a few floors higher. That is the most important thing. They don't look broken. They are not obviously broken in any way. Now, how does this apply to games? Let's look at the tiered pyramid. Before we talk about the tiered pyramid method as it actually applies to games, we need to talk about what are the components of the pyramid. So for this to make any sense, we should probably have a game in mind, right? So let's pretend we're making a first-person shooter. Everyone knows what a first-person shooter is. It's like a game where you see through the eyes of the character and you go around, usually have a gun weirdly attached to you, and wherever your head goes, the head goes and the gun goes too. They're really strange. Everyone knows kind of how they function though. So I'm using one of my own games here. It's called The Hunter. So it was one of the first games where I actually worked in this method, and it was actually a first-person shooting game, right? The best thing about those kinds of games is they're extremely simple in many ways. So we're going to use this as a basis because it simplifies things a whole lot. Now, the tiered pyramid that I'm going to teach you how to build is composed of the following components. First of all, you've got product tiers, feature tiers, feature subsets, and mechanics. Now, before we go into any detail about all of these, it's very important that you remember that these are just words, okay? Component number one, product tiers. I want to explain what a product tier is. A product tier is a horizontal slice of a product. Have you guys heard the word vertical slice? Someone has heard vertical slice. So basically, when you talk about a slice of a product, you're talking about a section of it that is supposed to indicate what the final game is going to be like. So when you say vertical slice, people are kind of imagining the game as kind of either a cake or like a square or whatever. But the point is that you are cutting out one level that is supposed to be at final quality. Oftentimes, publishers will actually ask for you to have a so-called vertical slice. They'll say, well, one of the most important milestones that you can have is the vertical slice milestone, because then we get to see one full level that works as in the final game. And we'll play that one and see, hey, is this going to be a good game, right? Now, a horizontal slice is a little bit different from that. Instead of taking one level that only contains the components necessary to make that level, a horizontal slice will in fact have every aspect of the game, but at a lower level of detail. This is a very important distinction, because if you have a horizontal slice, you get to play the whole game in a very basic way. If you have a vertical slice, you get to play a very short part of the game at a very advanced level. I prefer horizontal slices, and that's why I use them for the TPM method. So it should solve the high-level problem statements of the product. Now, you guys remember when we talked about mechanics, dynamics, and aesthetics, right? So what I want for a product here is that the aesthetic that you guys are going for is actually handled by that product here. And it should also be as small as it can be so that it's as easy as possible to implement, and contain every cross-dependent game component. Now, usually this kind of stuff is easier to visualize. I'm going to show you some graphics later, so it's going to be easier to understand. So a product here may feature downward dependencies and upward compatibilities. So what's the difference between a dependency and a compatibility? So a dependency is something that I need in order to function, right? So something that enables another feature. A compatibility may be something that you are prepared for but you don't need. So for example, you can be forward compatible with a new program that you don't actually know exists today. For instance, any operating system is going to be forward compatible with programs that haven't been written yet, right? But a dependency is something that you cannot live without, just to make sure that you guys know. So here's an example. If the final product is meant to be a first-person shooter with cover and grenades and dual wielding, you know, when you can have one weapon in each hand, product tier 1 can just be a humble on-foot FPS with a two-handed weapon. So let's visualize what we mean, right? So I'm calling this the tiered pyramid method. So it's basically that you're taking your product. This entire thing is your whole product, right? And your product here are these things, 1, 2, and 3. Horizontal slices that all of them actually continuously make the game better, but actually function alone as well, right? So in this example, we said we wanted to make an on-foot first-person shooter with guns. That can be our first tier, right? Our second tier can be that plus cover and grenades. So cover means that you can hide behind a car or like some wall or something like that. And then you can throw grenades at other people. And then finally, product tier 3 can be those things plus dual wielding, right? So it's constantly adding stuff by building on the stuff that's already existing, right? Now, we're going to stay on this slide for a little bit. And I have, I suppose, the most important question. You may have noticed that I've tagged the different product tiers. So I've basically said product tier 1 is crucial. Crucial means that we will not launch without it. We need to get that in there. Same with product tier 2. Now, product tier 3 says non-crucial. Anyone want to speculate why?
Because, you know, having two different weapons in your both hands, it doesn't change the core mechanics of the game. It's just having two different weapons in your hand.
Anyone disagree with that?
Just a bonus.
Yeah, well, the thing is, as you say, it's a bonus. It doesn't change anything. So basically, the dual wielding, having one weapon in each hand, solves a problem that you already solved down here. Shooting stuff in the face. Now you can do it like this. But basically, it's the same thing. So it means that even if we don't get that stuff in there, the game still functions almost 100% the same. Almost. There's some nuance to dual wielding. You can have, you know, the small sawed-off shotgun here and the 9mm in this hand, and maybe that's different from having two 9mm. Sure, but still, it doesn't fundamentally add to the game that much. That said, could you not say that this one is also non-crucial?
In some case.
Yeah.
Well, the thing is, these tags for me are a little bit arbitrary. I could have just said that the only one that's crucial is this very first one, because we need to have something, otherwise there's nothing to launch. We can't make a game that's just an art project. You know, like the paintings that are just white square on white background, and someone just took a white piece of paper and put that in an art gallery, and you have a bunch of people going, that's very interesting. No, it's not. It's a white piece of paper, you idiot. But we have to launch something. So that's our first tier. So of course we need to have that. But this one doesn't intrinsically have to be crucial. It just is in this case. Maybe it's a political thing, right? Maybe it could be that the publisher says we will not launch unless we have cover and grenades. Because if we don't have cover and grenades, we feel like a 1998 game. It just feels too old school. We don't want that. Okay, so they say that they have to have that, then we have to have that, right? Mechanically, you could probably launch down here already. This is basically the feature set of Doom, the original Doom. It was good enough back then. I think you can make it work today too, depending on which platform you're on, right? So does that make sense to everyone? Okay. So number 2, feature tiers. Now, feature tiers are the cross-dependent components that make up a product tier. They are isolated but fully functional stepping stones toward the final goal of that feature. Let's visualize what we mean by this. So we have all this from the slides before, right? What's a feature tier? Well, these are feature tiers. The feature could be user interface and menus, so the stuff that you use to actually go in and change your equipment and all this kind of stuff. Opposition and AI, player mechanics, environment and objects, and weapons and items. Now, these are not really that many of them, but just for the sake of this example. Now, you'll notice that it says 1 after all of these. Why? Well, because they all go into product tier 1. Incidentally, some of them continue upwards. When you get to product tier 2, some of them actually come with. You remember that we said we need a first-person shooter with weapons, and that's pretty much all we need. And then we're going to add cover and grenades. Then we have opposition AI 2, and we have player mechanics 2, and we have environment and objects 2, and weapons and items 2. We don't have any user interface and menus 2 in this case. We could have, but in this instance, we already have enough user interface and menus. Maybe there's a user interface. I'm sorry?
How about the grenade? You don't do it.
Yeah, but you don't know. Maybe I'm a genius. Maybe I figured out some way of doing it otherwise. Yeah. No, but yeah, it's possible that you might actually need user interface and menus to be able to find the grenade or whatever. But let's say in this instance you don't. Maybe it's actually done by some button that doesn't actually need any additional user interface. It's just a special button. Say. Good catch, by the way. Anyway, there could be a new user interface and menus that comes up here. So it doesn't always have to go sequentially. It doesn't have to work that way. But the important thing is when you're adding your cover and your grenades, you will need to update your opposition and AI. The enemies need to know that now you can throw grenades and they can throw grenades at you. Otherwise, it's going to be a very easy game. Player mechanics too. Well, you need some way of actually throwing those grenades, right? Environment and objects too. We said cover. Well, you should probably have cover objects because it doesn't happen automatically. You need to actually define what a cover object is. Weapons and items, well, you need the grenades, right? Pretty straightforward, right? And it continues like this. Same thing here. For adding dual wielding, we didn't really need to add any new environment or objects. We just needed opposition AI 3, player mechanics 3, and weapons and items 3, just to accommodate what we said, right? But does this make sense? So as you are adding stuff to the entirety of the game, you are actually upgrading some of the features in there. But they work even when they're not at 100%. You can actually visualize this as being 1/3, another third, the final third, right? Again, it's a very simplistic way of looking at it, but it's a very useful way of looking at it because it's a way of making your 25% done be 100% done for that tier. Because if someone runs out of money or for some other reason you can't actually continue the project, you can at least launch. You don't have to spend another month wrapping everything up again, right? And another important thing, you remember how we talked about dependencies? Look, dependencies, right? There are only dependencies within the same product here. Within the same product here, but also downwards. Downwards is fine, right? Sideways and downwards, perfectly fine. No, you must not do that. Because the second you go upwards in any way, you're waiting. You might as well just take away these. And if you had a dependency upwards at that point, you could just as well just call this product here 1 and be done with it, right? This is very important, and this is the entirety of it. I could just send you home now, but I'm not gonna, because I love to see you guys sweat. Anyway, feature subsets. Feature subsets are the cross-dependent components that make up a feature tier. Feature tier, remember? That's a feature tier. Let's visualize them. So player mechanics 1, was composed of movement 1, weapon usage 1, item usage 1, and uncategorized mechanics 1. I don't even know what goes in there. That's usually my category for all the stuff that I forget. So I just have like other as a category because I always forget a bunch of stuff and I have to add it in later. So these guys are feature subsets. These are the guys that actually make up your player mechanics 1, right? And to just illustrate why there is cross-dependency, let's just look at, we don't have to look at all the, because we had 5 feature tiers in there. But let's just look at these 3 and we can actually identify for player mechanics 1 why there are cross-dependencies. The cross-dependencies aren't really as much at the very top level. They're actually here at the subsets when you think about it, right? Because you know, you need weapons and items that you can use with your user interface and menus, or you can equip with your user interface and menu, which goes back into the player mechanics that you can actually, right? So you see how that actually functions. In fact, it is these things that are dependent on each other. It's not so much this. Now, lastly, mechanics. Mechanics are the lowest level components that make up the feature subset. So this is one way of visualizing a mechanic. So this is, remember we had movement 1 on the previous slide. So this is movement 1-1, and this is a very simple way of actually writing a mechanic in a way where everyone can kind of understand this. If you guys are planning in ScrumWorks or Handsoft or Excel or something like that, for every mechanic you have in the game, I would recommend having it written down kind of like this. You have your contents summary that says a WASD controlled, disembodied, which means free-flying, gravity-constrained camera. So it's a camera that is floating off the ground that you can actually control with your WASD keys, right? Ideally the mouse as well. You've got your speed settings, your head movement, your distance from the ground. It also says which assets are enabled. So once you actually have the camera that can move around in the game world, it enables you to create certain assets. For instance, if you have a player character, it's probably a good idea to know at what distance from the ground the camera is going to be before making the character model, right? So it's good to track, like, what can you make once you've implemented this? What assets can you make once you've implemented this? It also has stuff like requirements and you know, white room testing environment, for instance. This is important. You cannot test movement without having a space to test the movement in. So you probably need at least a white room with metric grid on the ground so you can test speeds, right? Now the most important thing of this slide is at the very bottom. So you guys remember how we were talking about reducible complexity? I need you guys to always have at least 2 definitions of done. Does that make sense? Definition of done? So I need you guys to define to yourselves when you're finished. When are you done with something? This is one of the most difficult and important things to do that a lot of people miss just because it's so difficult. But if you don't do it, you're going to end up in development limbo. You need to know when you are finished with the task, and ideally you should split that up in at least 2. If possible, it should be even more than that, right? My base level definition of done that I use for everything. So when I say base level, this means that it's not releasable. You can't actually release it to the end consumer, but it's good enough for the needs of the team. So my standard base level definition of done or finished is when all the parameters are available. So all the different parameters that I need to have to tweak, so the speed of the camera as it's moving around and all these other things, they have to be available for me to be able to say that it's done at a base level. Also, I want the parameters to be set at a first pass. So whoever is the designer, whoever owns the parameters, should have set them to an initial pass. So whatever I think the speed kind of sort of should be in the game, because when we sit down, the entire team, and we have a meeting together and we look at the game, I want people to see kind of what speed I would like the entire game to play at. It's an important thing. And then finally, preliminary and placeholder assets. So I just want to have something in there to get a better visualization of what's going on in the game. Not releasable assets. It doesn't have to be the final character model, the final textures, nothing like that, but just have some base level assets so that we can look at it and say, is this going in the right direction or is it going in the wrong direction? And that is it. Another way of saying base level is testable, right? Testable in the sense that we can decide as a team whether we're going to keep working on it or throw it away. And base level definition of done should be something that you can reach in a week or less. And this is on a big project. If you're on a small project, we're talking hours, right? Sometimes you can find some abstract way of trying the same thing. If you can prototype it with paper and pen, do that. But you need some way of testing it out so that you can test your mechanics, dynamics, and aesthetics, and then decide whether you're keeping it and going for the next one. Because the next one is your release level definition of done. And when you're going for release level, you want to have the parameters signed off by the lead designer. So whoever decides when the speed of the camera is correct has to be okay with the speed, saying, yeah, this feels 100% right. And the assets, so the graphics and audio, need to be signed off by the art lead or audio lead or both, right? So that's a pretty high threshold to hit. It's just two things, but it's a big deal. Because the lead designer has to be, I'm fine with those speeds for the final game. Usually what he says or she is, I'm fine with that for the final game for now, but it's such an easy fix, we can go back to it. And usually that's not a big deal. Just changing a number is not a big thing. But the other one is more difficult. You need to get the art director and the audio director to both say, yeah, this is good enough for the final quality. And that's when you're 100% done with it, right? So at least 2 levels of done. Number 1, just to see if you're going in the right direction. Number 2, launchable. If you can do 3 or 4, that's even better, right? So again, this is a mechanic. So just to visualize where all of this actually ends up in the grand scheme of things, this is the mechanic that we just looked at. This is another one that is dependent on it. So this is mechanic, this is the movement 1-1, and this is movement 1-2. This is a different mechanic. So this is the variation in stances. So you can be standing, crouching, and then down on your stomach, which I'm not doing. So that's a separate thing, and that one only works if this one already exists. So you have a priority here too. But we need to have both of these go into movement 1 so that we can have movement 1 done, and that's part of player mechanics. So if you were to zoom this entire thing out, you would see that what we're basically doing is we're looking at the pyramid and we're just looking closer and closer and closer down to whatever is you can actually implement, right? So just to repeat, tiered pyramid is composed of product tiers, feature tiers, feature subsets, and mechanics. And don't forget, these are still just words. By that I mean, if you guys forget the terminology, just don't forget the principle. If you want to call this, Peter, Eric, Özkan, and Ted, okay. That doesn't matter. It's okay. It's not copyrighted. Just do what you want.